Hello everyone. I'm going to be going through an ideal gas question from the 2023 AS Paper 1. Yeah, 5 marks. Let's just get straight into it. So they're telling us that M is a group 2 metal and it forms the nitrate with this formula. And they're telling us that 0.32 grams of this is heated strongly and decomposes completely. And we're going to form this equation, right? And they're telling us that the mixture of gases formed has a volume of 225 centimeters cubed, 450 degrees Celsius, and 101,000 pascals, right? And they want us to determine the MR of the nitrate and also identify M. And it's nice that they've given us that R is 8.31, which is a big hint to us that we're going to be needing to use PV equals nRT, right? So let's just write that out. That's always going to be worth a mark, guys. And in this case, we're going to be solving for N. So let's rearrange the equation. So N is going to be equal to PV divided by RT, right? Now, we need to do a bit of unit conversion, right? So P is always measured in pascals, so that's actually great because we don't have to convert anything there. However, our volume is measured in centimeters cubed and we need to be measuring that in meters cubed. So the way I like to think about this is if you're converting from centimeter to a meter, you're going to be dividing by 100. So by volume scale factors, if you're going from centimeters cubed to meters cubed, you're dividing by 100 cubed, right? So therefore our volume is going to equal to 225 divided by 100 cubed, which is equal to 2.25 times 10 to the minus 4. R we've already been given, which is lovely, and T, our temperature, needs to be given in Kelvin, but it's currently given in degrees Celsius. So to convert from degrees Celsius to Kelvin, you just have to add 273. So T is going to be 450 plus 273, which is equal to 723, right? Now let's just sub in our values, right? So N is going to equal to 101,000 times that by 2.25 times 10 to the minus 4 all over 8.31 times by 723. So our value of N is going to equal to 3.78 times 10 to the minus 3 mole, right? And that's going to be equal to our volume of our moles of gas, sorry, which is the 4 moles of nitrogen dioxide and the 1 mole of oxygen, right? So our nitrate is decomposing in a 2 to 5 ratio with the gases. So that means to find our moles of nitrate that's decomposing, we can just times by 2 over 5, right? So our moles of M3 is going to equal to 3.78 times 10 to the minus 3 times by 2 over 5, which is going to get us an answer of 1.51 times 10 to the minus 3 mole. And we want to find the MR of our nitrate, and we've already been given the mass that we've used to decompose. So we can find the MR by doing mass divided by moles. So the MR of our nitrate is going to equal to 0.32 divided by 1.51 times 10 to the minus 3, which is equal to 211.5, which is equal to 212 to 3 significant figures. So that's one of our answers. And now we just need to identify M. So we can find the MR of the NO3 part, right? So this is going to be equal to 2 times 14, as we've got 2 nitrogen atoms, and then 6 times 16, as we've got 6 oxygen atoms, which equals 124. Therefore, our MR of M is going to be equal to 212 subtract 124, which equals 88. Now we just need to look down our periodic table, look down group 2, and look for a metal that's quite close to 88. And in this case, strontium has got an atomic mass of 87.6, I think it is. Or it might be 87.8. Not too sure. But which is approximately equal to 88. So therefore, our metal is going to be strontium, right? So yeah, that's our answer. All right, thank you guys for watching.